There is about 10 to 12 genes that drive the vast majority of CHIP and CCUS. And the most common ones are DNMT3A and TET2, and ASXL1 is the third most common. But these genes are actually beginning to appear in the population as drivers of chronic hematopoiesis as early as from the ages of 30 or 40. They increase in prevalence with age. They seem to, in isolation, carry a moderate risk, particularly DNMT3A carries, I would say, more low risk, apart from hotspot mutations in the RAT2 position of the gene. TET2 is a slightly higher risk, ASXL1 is slightly higher still, but as a group, they are not very high risk mutations, these, but they are the commonest. When you look at some of the less common mutations, like mutations in JAK2, for example, they are high-risk mutations for progression to myeloproliferative neoplasms, which they themselves are not as difficult a disease group as acute myeloid leukemia or myelodysplastic syndromes to manage. So even though it's a high-risk gene, the disease that develops is not so aggressive. Then CALR, another gene, which is not very common in chronic hematopoiesis, but goes with JAK2, does the same thing. But there is another group of genes, the splicing factor genes, SF3B1, SRSF2, and U2F1. Those are high-risk genes. When we see the clones driven by these genes, we see that they expand fast, and the risk of progression is also very high. So those genes, I think, could be ones to target in preventive interventions, but at present we don't really have many targeted therapies for these genes. Another couple of genes are the P53 gene and the PPM1D gene. P53 is a gene that we do see in myeloid malignancies, but we're still learning about the risk because heterozygous mutations in P53 do not look to carry a big risk, but homozygous mutations do. So it's another interesting area where there may be future intervention. And another, looking at chronic hematopoiesis from a broader context, we know that in certain scenarios, for example, individuals with telomere biology disorders, aplastic anemia, and people who have had chemotherapy, the types of chronic hematopoiesis are different. So we're learning a lot about how to understand and capture and modify chronic hematopoiesis in those individuals. So a whole lot of new insights, a whole lot of learning, and generally a very exciting field to be in.